Right, so we're gonna start this video off by first typing our skeleton as defined in the previous video. Okay, there we go. So next step is we want to set up the oscillator. That is the theme of this video. So firstly, I'm just going to nicely comment setting up the oscillator. I do hope I spelled it correctly. Oscillator. Oh no, I'll find out now. So table of contents, oscillator, I've spelled it correctly. So you go to the datasheet and table of contents, you click on oscillator module, it's a hyperlink. So this shows the intricate workings of the oscillator. So firstly, you can see here there is this internal oscillator. So firstly you have 16 megahertz and a 31 kilohertz source. So the 16 megahertz gets put into this post scaler, which is basically just a 1, 2, 3, 4, 5, 6, 7 bit adder that just rolls over. So those can be referenced using the mux. And then the 8th option of the mux could be this direct 31 kilohertz that is in the internal oscillator. So the 16 megahertz gets scaled and the 31 kilohertz is some kind of crystal or something that's just directly there. So you use the oscillator to change what frequency you want for, or you use the mux to select which frequency you want the microcontroller to work on. So that shows the internal oscillator that goes to the rest of the CPU and the peripherals. So this shows the intricate workings of the oscillator. So you see this oscon popping up all over the place. So this is the important register you need to use for the oscillator. So firstly, here is register 2-1, oscon, the oscillator control register. So IRCF are the 3 bits that are important here. So IRCF is kind of like a sub-register within this register, and IRCF is designated itself as IRCF bit 2 to IRCF bit 0. So how we're going to do this is we are first going to say, right, so there are new directives we need to learn. So there is BSF, which stand for bit set file, which basically just changes a register value to a 1. Right. Second is BCF, which is bit clear file, and that just changes a register value to a 0. Right. So BSF and BCF is what we're going to use to change the values of IRCF. Right. So now here are all the values or the possible combinations for IRCF. You will see at many times when you look at a register, for instance, there is an X. When it's an X, it means that if the other bits sequence of whatever is specified is those values, then this is don't care. So if the first bit is a 1, the second bit for this sub-register would be a don't care. It doesn't matter. If these are 0, you can clearly see it can be either a 0 or a 1. So with these 3, all possible combinations of those 2 bits have been denoted. But here, everything is clearly laid out. It's hard-coded. So you can see if you type 111, it takes the top value of the mux, which is directly from the post scaler. So if you want 16 megahertz, you make IRCF all the bits high. If you want 8 megahertz, for instance, you make the first 2 high and the third one low. So let's make a 16 megahertz, and right after we're going to make an 8 megahertz. So how you reference this is you say, right, so we want everything high. So we're going to say bit set file for everything. So firstly you type the register name, just like that, straight, comma. Now the thing with this is this sub-register has sub-bits. So normally you would just say, for instance, if you were working with 1 bit in one register, you would say oscon, comma, ID len, for instance. But because this is a sub-register with other bits, you will be saying comma IRCF2 and comma IRCF1 and comma IRCF0, just like that, directly. So we're going to type IRCF2 and that is it. So we're going to do this for the other 2 bits as well, comma IRCF1, and the last one, oscon IRCF0. Right, so this just set up the oscillator to 16 megahertz now. 16 megahertz, which is referenced as 3 ones. Right. So this should set up the oscillator to be fed to the CPU and all the other peripherals as 16 megahertz. So let's play around and let's say we wanted 8 megahertz. So because IRCF starts at 2 and ends at 0, the first bit here would be the bit number 2. So IRCF2 should be this value for all of these that you would select. So if you take 8 megahertz, then IRCF2 should be 1 and IRCF0 should be 0. So if you know the ennianness, which is the direction of bits of your register, you would see that the first bit, which is denoted as 2, should be 1. So let's change it, and then basically just the last one gets turned to 0. So that would be 1, that would be 1, and that would be 0, 1, 1, 0. So we're gonna change that just to nicely show. No. So there we have 8 megahertz. So if I compile this, it should compile nicely. There we go. So the oscillator should be set up right now. My, oh my. Lots of spelling mistakes today. Right. So as you see, we used the same skeleton as last time. We could have generated all the configuration bits, as you can see here, but we didn't, because it's a lot of extra unnecessary things that are already set up in a certain manner. So these are the only 3 that need to change. And yeah, the oscillator is set up real quick. It's these 3 lines. If you're in a test and you need to set up the oscillator, do it first. It counts marks. It doesn't count a lot of marks, but almost half of all your marks in a test, for instance, would be just this setup bits alone, because it's a lot of setup bits. The actual execution isn't even that much. So yeah, that's everything you need to know on the oscillator. See you in the next video.